For over 20 years, the Caterpillar 797F was the king of 400-ton mining haulage. 4,000 horsepower, fed through a mechanical drivetrain. Torque converter. Transmission. Drive shaft. Wheel hub. The kind of drivetrain logic that defined American heavy iron from the 1950s forward. If your mine moved more than 200,000 tons a day, you ran the 797F. That was the rule. Across the open-pit copper operations of South America, the iron ore mines of Western Australia, the oil sands of northern Alberta, the gold operations of southern Africa, CAT's mechanical drivetrain ultra-class haul truck defined what an ultra-class haul truck was supposed to be. Then, quietly, across the back half of the 2010s and through the 2020s, mining operators specifying new ultra-class fleets started writing a different model number on the order sheet. Liberty 284, 363 tons nominal payload. Diesel-electric series hybrid drivetrain. Ranked among the top 5 largest mining dump trucks in 2026. Built by a family-owned company, founded in 1949, that has, in the 77 years since, never had to file a shareholder-friendly quarterly earnings release in its life. The reason has nothing to do with the trucks themselves, and everything to do with 2 different corporate cultures making 2 different bets on what ultra-class mining haulage would look like in the 2020s. If this is your first time here, hit subscribe. We document the corporate decisions inside boardrooms in Peoria, Chicago, and Irving, Texas, that hollowed out one of the most respected industrial brands of the 20th century. The data tells the story. To understand why the switch is happening, you have to understand what the 2 drivetrain architectures actually do. The Caterpillar 797F uses a mechanical drivetrain. The diesel engine generates rotational power. That power goes through a torque converter that allows the engine to keep turning while the truck starts and stops under load. The torque converter feeds a transmission that selects gear ratios. The transmission feeds a drive shaft that turns the wheel hubs. It is the same drivetrain logic that runs in a heavy-duty highway truck, scaled up to 400-ton payload territory. The advantages are well understood. Mechanical drivetrains are mature technology. The component supply chain is deep. The dealer, technician base, knows how to service them. The reliability data across decades of mining operation is robust. When Caterpillar engineers in Peoria spent the 1980s and 1990s refining the mechanical drivetrain to handle ultra-class loads, they were building on 100 years of mechanical engineering pedigree. The Liebherr T284 uses a diesel-electric series hybrid drivetrain. The diesel engine generates rotational power. That power turns a generator. The generator produces electrical power. The electrical power feeds inverters and controllers. The controllers drive electric motors mounted in the wheel hubs. The wheel hub motors turn the wheels. There is no torque converter. There is no mechanical transmission. There is no drive shaft. The drivetrain converts diesel fuel into electrical energy, and then converts electrical energy into wheel torque. The advantages in the context of ultra-class mining haulage are structural and increasingly decisive. Electric wheel motors deliver full torque from 0 RPM, which is exactly what an ultra-class truck needs when starting a fully loaded climb out of a deep pit. The electrical drivetrain runs more efficiently across the full range of operating speeds than a mechanical drivetrain optimized for a narrower band. The wheel hub motors are modular. They can be replaced individually without dropping a transmission. The architecture is naturally compatible with regenerative braking, which captures energy on downhill segments and feeds it back into the drivetrain. The architecture is naturally compatible with trolley assist infrastructure, which runs the truck on overhead grid power along the haul road and saves diesel for the segments where grid connection is not available. And, critically, for the next 20 years of mining decarbonization, the architecture is naturally compatible with battery electric conversion. A battery electric ultra-class truck uses the same wheel hub motors, the same controllers, the same inverters. The only thing that changes is the energy source. CAT understood the diesel-electric architecture. CAT has the engineering talent to build it. CAT could have made the bet to develop a diesel-electric ultra-class platform alongside the 797F mechanical platform 15 years ago. The decision was not made. The corporate priorities did not support it. The R&D investment that would have been required to build a credible diesel-electric ultra-class platform competing head-to-head with the Liebherr T284 was the kind of long-horizon engineering investment that, in the corporate culture that took over Caterpillar somewhere in the last 15 years, does not move the next quarterly earnings number. The share buyback programs got the cash. The headquarters moves got the executive attention. In 2017, the headquarters left Peoria for the Chicago area. In June 2022, the headquarters left Chicago for Irving, Texas. The engineering culture that would have driven a clean-sheet diesel-electric ultra-class platform drained out of the company, while the diesel-electric architecture was eating market share in the segment Cat had. Defined. Liebherr made a different bet, because Liebherr operates under a different corporate logic. The company was founded by Hans Liebherr in 1949, in the post-war Reconstruction era, as a manufacturer of mobile tower cranes. The company is still entirely owned by the Liebherr family. There are no public shareholders. There are no quarterly earnings calls. There is no pressure from Wall Street to compress R&D as a percentage of revenue to fund share buybacks. The Liebherr family makes capital allocation decisions on a generational timescale. When the family decides that the mining division should invest hundreds of millions in developing a diesel-electric ultra-class platform that will pay back over a 20-year horizon, the family makes that decision, and the engineering team executes against it. The investor relations function does not exist. The activist shareholder threat does not exist. The pressure to optimize next quarter at the expense of next decade does not exist. 77 years of single-family ownership produces a different operating system than 77 years of public market ownership, and the 797F versus T284 contrast is what the operating system difference looks like when you reduce it to a single product comparison. Quick break before we get into what happened next. If you're following how Caterpillar lost segment after segment, subscribe so the next one lands in your feed. Now back to it. By 2026, the Liebherr T284 ranks among the top 5 largest mining dump trucks in the world. The deployed fleet is concentrated at major mining operations across multiple continents. Australian iron ore operations, Chilean copper operations, North American mining projects, Southern African platinum operations have all specified T284 units in fleet expansions or replacements. Specific orders for additional Liebherr ultra-class units, including electric variants, have been announced by major mining operators over the last several years. Where unit counts on specific orders are not independently verifiable, the qualitative picture is unambiguous. The diesel-electric ultra-class haul truck segment, which Cat could have owned by making the engineering bet 15 years ago, is now substantially Liebherr's territory. Komatsu, with its own diesel-electric experience and the Joy Global acquisition in 2017 that brought ultra-class haulage expertise, is the other major player. Cat, with the 797F still in the 400-ton mechanical segment, holds its position there, but increasingly finds itself bidding against Liebherr and Komatsu in the segments where the diesel-electric architecture is the controlling preference. The trolley assist story compounds the gap. Trolley assist infrastructure runs ultra-class haul trucks on overhead grid power along long, steep haul road segments. The truck pantograph contacts the overhead catenary, draws grid power, runs the wheel hub motors directly on electricity, and saves diesel fuel for the segments where grid connection is not available. Operations including Boliden's Aitik copper mine in Sweden, several Chilean copper operations, and a growing list of Canadian and African mine sites have deployed or are deploying trolley assist systems. The diesel-electric drivetrain architecture is structurally compatible with trolley assist. The mechanical drivetrain architecture is not. As mining operations push toward lower diesel consumption per ton hauled, the truck purchase decision starts to factor in trolley assist compatibility, and the Liebherr T284 has the structural advantage. Cat could re-engineer the 797F architecture to integrate diesel-electric drive, but doing so would effectively be a clean-sheet platform program, which is exactly the kind of long-horizon R&D bet that the captive corporate decision pattern in Irving, Texas, does not support. The family ownership story matters in ways that do not always show up in product specifications. The Liebherr engineer working on the T284 diesel-electric platform knows that the program will not be canceled because Wall Street analysts decided the R&D spend was hurting next quarter's earnings, per share. The Liebherr engineer knows that the company's commitment to the diesel-electric architecture is generational, not quarterly. The institutional memory accumulates. The technical expertise compounds. The customer relationships deepen because the customer knows the platform will still be supported in 15 years. CAD engineers, equally talented and equally committed to their craft, work inside a corporate operating system that has been quietly extracting cash flow to fund share buybacks and managing real estate decisions in Irving, Texas. The talent gap is not the issue. The corporate culture gap is the issue. And the operating system gap shows up in the procurement bid sheet at every major mining operation specifying a new ultra-class fleet for the next decade. The Liebherr family ownership story has historical depth that makes the long-horizon engineering bets institutionally consistent. Hans Liebherr founded the company in 1949 to manufacture mobile tower cranes for the post-war German construction-reconstruction effort. The first product was the TK-10 mobile tower crane, designed to be transported on a truck chassis and erected at the construction site in hours rather than days. The product solved a real construction industry problem at the right time and built the cash flow that funded the company's expansion into other heavy equipment categories over the following decades. The Liebherr Group today operates across multiple industrial segments, including mining equipment, construction equipment, mobile and crawler cranes, container handling equipment, aerospace, refrigeration, and household appliances. The breadth of the portfolio is the kind of breadth that public market shareholders, optimizing for return on capital, would have demanded be broken up and refocused on the highest return segments. The Liebherr family has not broken it up. The diversified industrial conglomerate structure that the family has maintained for 77 years allows cash flow from mature segments to fund long-horizon R&D investments in segments that take 20 years to pay back. The diesel-electric ultra-class haul truck program is exactly that kind of long-horizon investment. The shareholder primacy operating model would not have funded it. The family ownership operating model did fund it. The result, 20 years later, is the T284 platform that mining operators worldwide are increasingly choosing over the Caterpillar mechanical drive alternative. The technical detail of how the T284 drivetrain works in mining operating conditions is worth understanding because it explains why the diesel-electric advantage compounds over time rather than diminishing. The diesel engine in the T284 runs at near constant speed, regardless of the truck's wheel speed. The diesel engine drives a generator that produces alternating current. The alternating current is rectified to direct current, then inverted to controlled three-phase alternating current that drives the wheel hub motors. The drivetrain electronics allow precise torque control at each individual wheel hub, which translates into smoother power delivery during load-up from a standing start, better wheel slip management on loose haul road surfaces, and finer braking control during downhill loaded descents. The regenerative braking captures kinetic energy during downhill segments and either returns it to drive other wheels uphill of the descending wheels or dissipates it through resistor banks during pure braking operations. The fuel efficiency advantage over the mechanical drivetrain ranges from a few percent in flat haul applications to double-digit percentage points in operations with significant elevation change in the haul cycle. Over the asset life of an ultra-class haul truck operating 16 hours a day for 15 years, those efficiency differences compound into substantial fuel cost savings and substantial reductions in diesel fuel-related carbon emissions. Mining operations under regulatory pressure to reduce per-ton emissions, which increasingly includes operations in jurisdictions with carbon pricing and operations under ESG investor pressure, find the diesel-electric drivetrain advantage decisive in fleet replacement decisions. The trolley assist deployment story compounds the underlying architecture advantage. Bolidens' Aitik copper mine in northern Sweden was one of the early operations to deploy trolley assist infrastructure at scale, with overhead catenary lines installed along the main uphill haul road segments. Trucks running the trolley assist segments draw grid power directly through pantographs mounted on the truck cab, drive the wheel hub motors on grid electricity rather than diesel-generated electricity, and reserve diesel fuel consumption for the segments where grid connection is not available. The diesel fuel savings per truck on a trolley assist deployment can run to 50% or more of the total fuel consumption, depending on the proportion of the haul cycle that runs under grid power. The infrastructure investment to install trolley assist catenary is substantial, but the payback over the fleet life can be attractive in operations with long, steep, repetitive, uphill haul road segments. Several Chilean copper operations, several South African platinum operations, and a growing list of operations in Canada and Australia have deployed, or are studying, trolley assist deployments. The trucks running under trolley assist infrastructure are diesel-electric platforms, most commonly Komatsu 930E units and Liebherr T284 units. CAT 797F units cannot be retrofitted to run trolley assist because the mechanical drivetrain architecture is not structurally compatible with grid power input to wheel hub electric motors. The trolley assist trajectory is therefore a structural CAT exclusion zone for as long as the 797F remains the primary CAT ultra-class platform. Caterpillar remains a major ultra-class haul truck supplier. The 797F is still the king of 400-ton mechanical haulage in many segments. The CAT dealer network in mining-heavy regions, including Latin America, Sub-Saharan Africa, and Australia, is genuinely unmatched in raw scale. The shift to Liebherr T284 is documented in specific procurement decisions, where the diesel-electric drivetrain architecture or the family-owned engineering culture carried the decision. The accurate framing is that CAT lost the structural bet on diesel-electric ultra-class haulage to a family-owned competitor that made the bet 15 years earlier. The framing is segment-specific, not total abandonment. The competitive comparison between Liebherr and Komatsu in the diesel-electric ultra-class segment is worth a brief mention because both companies have built leading positions through different corporate routes. Komatsu is a publicly listed Japanese company with a long-horizon engineering culture that has resisted the worst excesses of the shareholder primacy operating model that took over American industrial companies. Komatsu's diesel-electric ultra-class platforms, including the 930E, have built deployed fleet positions through patient engineering investment over multiple product generations. Liebherr's diesel-electric ultra-class platform, the T284, has built its deployed fleet position through the patient capital that family ownership provides. Both companies have outperformed Caterpillar in this segment for similar structural reasons, even though their corporate governance models are different. The mining customer choosing between Komatsu and Liebherr for new ultra-class fleet decisions weighs other factors, including specific drivetrain performance characteristics, dealer service presence in the local region, integration with existing fleet management systems, and the price and financing terms of the bid. The customer choosing either Komatsu or Liebherr over Caterpillar is making a procurement decision driven by the diesel-electric architecture advantage, the engineering culture advantage, or both. This video is the Liebherr-specific story. The channel has a separate video covering Asian mining trucks more broadly, including Komatsu's role in the ultra-class segment, and that earlier video frames the Asian competitive picture. The T284 story is its own story, with its own drivetrain logic, its own family ownership backdrop, and its own 77-year corporate timeline running parallel to, and largely opposite to, the American shareholder primacy timeline that drained the engineering culture out of Peoria. If you've operated a Liebherr T284 or Spec 1 for a mining fleet in the last decade, drop the operation and the year in the comments. Tell me how the bid came down between CAT and Liebherr. Let's see how many of us watched the diesel-electric drivetrain win on real haul roads. Every operator who switched to Liebherr a decade ago saw this coming long before the boardroom in Texas admitted it. The fuel bills told the story. The dealer responses told the story. The diesel-electric cycle data told the story. The smart professionals read it early. The MBAs are still pretending they didn't. See you in the next one.